Hey, 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 ho, ho, ho. It is time for your trigonometry final exam review. So this is coming to you live from Online Math Resources for Students. Okay, so if you click on our trigonometry tab, click on the test review materials. We are working today on version B that will be uploaded down here. So the blank review document is not there, but it will be soon enough. The solution guide we are doing as we do this video, and the video we are recording right now. So all of this will be uploaded ASAP as soon as we are done with this. Just real quick, go right back up here. You see this, it says final exam under test 3. This is not the final exam for our class. There are some trig classes that just do 3 tests where the third test is exam 3. So do not click on this. This will only be over exam 3, and you will probably fail the final exam because you'll be like, where the heck are all these questions coming from that were not on that review? So right here, this is the accumulative review final exam. This is accumulative from chapter 9, 10, and 11. That's what makes up this final exam. So let's get started. So coming to you from all the way in 9.1, okay, they want us to take pi over 2 and convert it into degrees. Real quick, I want to grab my textbook. I mean, I know how to do this, but what I want to do is I want to make sure that I tell you guys all the right sections for every question. Pretty much this exam is going to go in order from the beginning to the end. There's very little where it will sometimes jump around, but I do want to make sure that you know where each question is coming from. And this is definitely a 9-1 question. So how do we convert this to degrees? Remember, it's a little conversion where we put 180 degrees over pi. So if you're going from radians into degrees, you multiply by 180 over pi. If you're going from degrees into radians, then you do the reciprocal of this. So you would multiply by pi over 180, just to kind of give you the rest of this. All right, so basically what's going to happen is your pi's are going to cancel, and all you really need to do is take 180 and divide it by 2. Again, you can also go to your calculator. Remember, you got this lovely alpha y equals button right here. And if you ignore the pi's, what you're really doing is taking a half, because this used to be pi over 2, and you're going to multiply that by alpha y equals, silly computer, 180 over 1. Again, where the 1's are, that used to be where the pi was. So this is pi over 2 times 180 over pi. You can ignore the pi's because they're just going to cancel each other out. And then there you go. In other words, really what was going on, it's 180 divided by 2. So our answer, pi over 2, is really 90 degrees. And there you go. Moving on. Number 2. Okay, number 2, this one is coming to you live from 9.2, if I remember correctly. Let me just double check. And yes, coming to you from 9.2 / it could also be 9.5, because this is where we really learned how to write those trig functions based off of what we know, okay? So we got sine of alpha equal to -7 over 25, and cosine of alpha equal to -24 over 25. Okay? So they want us to find the rest of the functions. Tangent alpha, secant alpha, cosecant alpha, and cotangent alpha. All right. So a couple things when we look at this. So remember, how is sine made? Well, one thing is, if you're thinking about this as the unit circle, if this was on the unit circle, which is what we learned about in 9.2, sine of whatever our angle is y. Cosine of whatever our angle is x. So you can call this y and this one x, and then you can go through and figure out all these. Because tangent is equal to y over x. Secant is the reciprocal of cosine. Okay? Give me a second. Okay? So the reciprocal of cosine looks like 1 over x. Cosecant is the reciprocal of sine, so that's 1 over y. And cotangent is the reciprocal of tangent, which gives you x over y. So that was one way. This is what we learned in 9.2. In 9.5, when it was just based on any old circle, it's not the unit circle, but it's any circle, where sine of theta is equal to y over r. And r is the radius of our circle, where in the unit circle, you already knew what r was. R was 1. And cosine theta is equal to x over r. So you could treat these as those two pieces, okay? So you could either think of this as the variable y, or you could think of this as y over r, okay? And the same thing over here. So it doesn't really matter what your train of thought is, because again, down here, tangent is going to be y over x. This is according to 9.5. This will still be, this will actually become r over x. This guy will actually become r over y, because your r is some sort of number. And this guy will become your y over, or sorry, not y over x, x over y. Silly Mr. Armstrong and his mistakes. So all depends upon how you want to look at this thing. All right. Give that a moment to dry real quick. X over y. So either you're 9.1 thinking, or sorry, 9.2 thinking, or 9.5 thinking. Okay, it's your choice on how you want to deal with this. I'm going to think of it in terms of the 9.5. It's easy because I like to give these two pieces. Now, remember that the negative was originally out front of this. So where do I put the negative? Because remember, the negative number can either go in the top or the bottom. Remember, negative numbers can either go in front or in the top or in the bottom. Because I am thinking about this in terms of the 9.5, r is a radius. Just so you know, a radius can never be negative. So that means the r has to be the positive value, which means we're just going to take that negative and shove it up to the top. So now you know that your y value is a -7. The same thing with the cosine. I already put the negative up top, but it could have gone either way. But just remember, since we're doing 9.5, since r is the bottom value, it has to stay a positive. So r is a positive 25, and our x value is -24. So here's our point. Here's the radius of the circle. Okay? So then all we do is we fill in the rest. Okay, so this is the x, this is the y. And when we fill in, we get -7 over -24. which that becomes 7 over 24. So there's our tangent. Secant is r over x, so that'll be 25 over negative 24. And again, I could move the negative out front if I want. I could have moved the negative to the top if I really wanted, but this is just as fine as of an answer. Right here, you get 25 over your y value, which is negative 7. And last but not least, put our x, which is negative 24, over our y value, which is a negative 7. And then again, a negative over a negative becomes a positive. And there's our answers. Either way you think about it, you get the same answer. If you did the unit circle, you'd have a little bit of math going on here. Let's just talk about that if we did the unit circle. So if we did the y over the x, you would have had negative 7 over 25 divided by the x value, which would then negative 24 over 25. We don't divide by fractions, we multiply. So what you really have is negative 7 over 25 times keep, change, flip, 25 over negative 24. The 25s cancel, which gives you the negative 7 over the negative 24, which is a positive 7 over 24. Okay? And then all you would have done for secant and cosecant is just flip these. So the reciprocal of negative 24 over 25 is 25 over negative 24. See? And then the cotangent would have worked the same way as the tangent, just kind of a note there. So if you actually did the unit circle version. Okay. All right, number 3. Let's talk about it. So here, just a graphing question. This is coming from 9.3. So they're telling you that y is equal to 2 sine 5x minus 4. Okay? So first things first, they want to know the amplitude, the period, and the phase shift. All right, well, not too hard to do. So in here, though, we need to fix this because remember that our equations are going to look like this. C plus or minus A, and then your trig function here, B parenthesis X minus D. Parenthesis. So you see how in here there's a B with a parenthesis. Over in here there isn't. So that tells us that we need to pull out a GCF. Whenever it doesn't look like this inside the trig function, it's a GCF idea. Okay? So in order to fix this, pull out a GCF. And that GCF is always the number in front of X. So what we're really looking at is this. We're going to pull out a 5, and that's going to leave us with X. See, parenthesis, 5 parenthesis X. Oh, look, B parenthesis X. And then minus, and then because we're pulling out a GCF, that just means we divide everybody in here. So this gives us 4/5. Now that we have this in the proper order and it looks like what we're dealing with up here, we can start answering the question. The amplitude, we can find the period, and we can find the phase shift. So remember that A is all about the amplitude. So what is our amplitude of this? What's our A? A is in front of the trig. So our amplitude is 2. Okay. B is all about the period. Okay. How we find that? In order to find the period, because we're dealing with sine and cosine, the period is going to be equal to, if I remember correctly, 2 pi divided by B. So all we need to do is take 2 pi divided by what's our B value. Our B is in front of the parenthesis. This is why we had to do that. Divided by 5. So right here, does this reduce down? No. So our period is 2 pi over 5. Okay. Our phase shift is whatever is happening with D. Okay. D controls the phase shift. Okay. So when we look at this, our phase shift, you're going to think the opposite of what you see. So this says a -4/5. Phase shift just means moving left or right. Because this is a -4/5, we're going to think the opposite. So that means we want to move to the right 4/5. Okay? You think the opposite of what you see here. You're going to move to the right 4/5 because it looks like a -4/5. All right? So we just need an answer that looks like this information. So if we come back in here, amplitude of 2, this is 2 pi over 5 because we just put the pi up top, and a phase shift of a +4/5. Hey, this one looks good right there. So the answer has to be A. If you look at the rest of them are all messed up. Okay? Because this one right here, the period is wrong. They say it's 5 pi over 2. And that is incorrect. Okay? This one, phase shift is wrong. And again, period and phase shift and amplitude are all wrong. So this guy is definitely A. All right? Okay. So moving on. Now you're actually going to graph. But remember, in order to graph this, really you guys are just filling in stuff in the computer. This is 9.3. And then there's one more graphing question after that, which number 5 is the 9.4. So there's really only kind of like two problems where you actually have to graph in this. So 3 cosine x minus pi over 12. Okay. So we want to graph this. Couple things. So in the computer, when you're dealing with this, they usually ask for the amplitude. They ask about the period. Sorry, just writing stuff down. The period, the phase shift, the vertical translation, and then they ask about reflections. If you can answer these 5 questions, you have all the information you need to put into the MyMathLab. And then the MyMathLab will generate the graph for you. Me, unfortunately, I have to generate the graph by hand. Okay? And I'll do that here in a second. All right. So, first things first. Let's jump to our information. This is good the way it is because the only number in front of x is 1. So you don't have to pull out a GCF there if you don't want to. But if you did, you'd be looking at this equation. Oops, I don't know why I put a y there. Should be x minus pi over 12. Easy fix. Minus pi over 12. All right. So what's our amplitude? Just like last time, it's the 3. So amplitude means that it's going to go up to a positive 3, down to a negative 3. Okay, as long as we don't vertically translate it up or down. So this is the height of our wave. It goes up 3, down 3, up 3, down to negative 3, up to 3, down to negative 3. Okay. Our period, well, our B is 1. The period of cosine is 2 pi normally. So we just take 2 pi divided by 1, and that's still 2 pi. So our period is still 2 pi, which means that it takes a length of 2 pi before it will start repeating again. Okay? So once you hit 2 pi, the pattern repeats itself. So it takes a length of 2 pi for one complete pattern of up and downs. Phase shift. We definitely have a phase shift. That's this guy right here. And so that means we're going to be moving to the right pi over 12. So a positive pi over 12. Vertical translation. That would be the number that is being added or subtracted in the beginning, and there isn't one. So that means there is no up or down movement, which means that I can actually graph 3 and negative 3. That's how high our graph will go. That's how low our graph will go, because we're not moving up and down. Reflections. Reflections are all based off of A. If A is negative, that means my graph will be flipped upside down. It'll reflect over the x-axis. Okay? So you look at your A, it's positive, so that means there is no reflection. If A was negative, if this was a negative 3, then we would have said reflect over the x-axis. Okay? So this is the information that you're actually going to put into MyMathLab. Some of these might have a sliding rule where you just slide it over. Like sometimes the phase shift does that. And sometimes the period does that as well too, where it's a slide rule. And all you do is you just slide it over to 2 pi and leave it. Or you slide it over to pi over 12 and leave it. Oops, if I could spell right correctly, put a T in there. Other times you're just typing it in. So when you type in pi into MyMathLab, remember you have to hit PI. Okay, and then it transforms the PI into the pi symbol. You don't actually have a symbol that you can actually use. You just type in PI. Okay, so sometimes these are sliding rules. Sometimes you're just typing them in. But you need to know the answers to these questions, and then it will kick out your proper graph. All right, so let me generate what this picture is going to look like. So the first thing is I need to slide my graph that originally happened from 0 to 2 pi over to the right pi over 12. So again, you're not doing this. I just got to do this by hand. Okay. So I know my graph will actually start at pi over 12. It's going to start there. Okay. My graph will end. Oops, if I could spell end right, not E-E-N-D, just E-N-D. My graph will end at pi over 12 plus 2 pi. So I'm just going to use my calculator figure. Again, you're not doing this by hand. You're putting in this information that I have right up here. So my graph should end at, so 1/12 plus 2. 25 pi over 12. So that's where my graph should end at. And then now that I know the beginning and the end, all I do is find 3 midpoints. Okay, so I know my graph will end at 25 pi over 12. All I did was take pi over 12 plus the period of 2 pi. That's how I got that. Okay? So the first one is I'm going to find the direct middle between these two. All I do is add these two numbers and divide by 2. So I'm going to take pi over 12. And I'm going to add it with 25 over 12. I'm ignoring the pi because I know I'm just going to put pi in the answer in the end. Divide that answer by 2. And I end up at 13 pi over 12. And then now I'm going to do is just find the midpoints between these two. So again, to find the midpoint here, all I'm going to do is add these two up. So 1/12 plus 13 over 12. Divide that answer by 2, and I get 7 pi over 12. And then I just add these two up and divide by 2. So 13 over 12 plus 25 over 12 divided by 2. I get 19 pi over 12. And now I can make my picture. So remember, when you do this, you'll have two graphs to select from. Your graphs will either look like this, or the graph will look like this. There are two buttons to select. If you actually hover over these with your mouse, it'll tell you if it's the sine or the cosine. Okay? But you should know that sine graphs look like this, cosine graphs look like this guy. Okay? So cosine starts up at the amplitude and then travels down and then back up. Sine graphs start on the axis. Okay? So we're going to come up here, and you guys should have selected this button. Okay? This is the sine. This is the cosine. So you select this. You put in your information, and then this is the graph that it will kick out for you. So at pi over 12, it's up at the amplitude. Then it comes down and hits the axis. Then it comes down and hits the amplitude. Then it comes back up. It hits the axis. And then it ends up at the amplitude. And it just keeps repeating and repeating and repeating that. So it goes down and then up. Just like that. Okay? And there you go. And then, of course, it would come down and hit the x-axis somewhere in here, or hit the y-axis somewhere up here, and things like that. But that's generally what the graph looks like. All right. Again, all you guys are doing is filling in this information and making sure you click on the cosine graph when you do it. This stuff I just did by hand, so I can give you a picture of what the graph should look like. So there's our graph. All right. Moving on to our last graphing question. Then you don't have to graph your trig anymore. Okay, well, at least like sine and cosine and all those kind of graphs. Okay, number 5. Number 5, as I said, is 9.4. That's where it's coming from. And this time we're going to graph a cosecant graph. Okay. So y equals 2 cosecant x. Oh, good. See, not that bad of a graph. All right. So really, all you have to worry about in this is the amplitude. Okay? Wrong one. Because there's no B and D. There's no C that's in front. So when you're dealing with this, if you're thinking about this, really the only thing you have to worry about is the amplitude. That amplitude is 2. Okay? So that means we need a graph that goes up to 2 and down to 2. The period's still 2 pi because cosecant and secant have the same period as sine and cosine. So since there's no B value, it's still 2 pi. And then as far as the phase shift goes, there is no phase shift. So there's no left and right. The vertical translation, there is none. So there's no up and down. And then if we look at our amplitude, this number is not negative. So a reflection, there is none. No reflection. Okay? Now, remember, secant and cosecant are based off of sine and cosine graphs. Secant and cosecant are based off of sine and cosine graphs. Okay? Since this is cosecant, it's based off of a sine graph because sine is the reciprocal of this. And all we're going to do is I'm going to graph a sine graph. I'm going to treat this like sine, and I'm going to graph that, and then and then again, all we do is, because these are reciprocals, we're going to it's kind of like we're going to flip the graph. Okay? So amplitude is 2, so it goes up to a positive 2, goes down to a negative 2. The period is 2 pi, and it doesn't move left or right, so we're going to have pi over 2. Pi, 3 pi over 2, 2 pi. Remember, sine starts on the axis. Cosine, remember, it started up above. Sine actually starts on the axis. And since there's no reflection, sine will travel up first. So it goes up to the amplitude, back down to the axis, down to the bottom of the amplitude, and back up to the axis. So this right here, I'm kind of dotting it because this is not the end of the graph, is what this sine graph would have looked like. Now, how we turn this into cosecant, anywhere where it hits the axis becomes asymptotes. So anywhere where we hit the x-axis, we're going to draw dotted lines through there because these are our asymptotes. So there's our asymptotes. And then all we do, remember that cosecant is the reciprocal of sine. So with reciprocals, we flip it. So there's the flip of that graph. There's the flip of that piece of the graph. This is what 2 cosecant x looks like. So we just got to find the picture that matches that. Okay? And the picture that matches that is number B, or B, not number B. That's just weird. B is our graph. Which yeah, oh yeah. Yep. Sorry. I was looking at this and I thought this little mark right there was 2 pi, but 2 pi is actually right here at the very, very end. Okay. So yeah, B is our graph. This one right here, this is a picture of tangent, if I remember correctly. Let me look. Yep. That is a tangent graph right there. And this one right here, this is actually our sine graph. This is actually our sine graph, the very first one that we did. So this is what the sine graph looks like. And then all we did was just put in our asymptotes and flip it. This one right here, that's a secant graph. So if we had 2 secant x, this would have been the graph for part D. Okay. Moving on. And that ends our trip through Graphland. So now, all about the trig. Okay. All right, so 6. And I don't know if I told you this, but there are 35 questions on this final exam. There are 35 questions on this final exam. All right, so 6. This one is definitely coming from 9.5 for surezies. So if you want to go back and that number 2 that we talked about, how I said it's 9.2 or 9.95, this is probably a 9.2. The reason why I said you could do a 9.5 to this, because it doesn't say anywhere in here that it is on the unit circle. That's why I said you could do it either way. But they probably meant to be the unit circle here. It's fine. All right. So the first thing says we've got this point that is -3, 0, and they want to know which picture is the standard position. Okay. So with standard position, let's jump over here, and then it wants us to find the 6 trig functions. So that's not too hard. We'll do that here in a second. With standard position, so 3, we'll make this easy for us. 3, -3, -3. Standard position, you have a beginning ray that starts here. Okay. And then from there, we have a terminal ray that ends out somewhere within these spaces. And the terminal ray always rotates counterclockwise because theta should be positive. Okay, so we like our theta, our angle, to be positive, which means we're going to rotate counterclockwise. So all we have to do is plot this point. So there is the terminal ray. And the angle should have rotated like that. So we need a picture that looks like this. And that would be A. It's the only one that actually has -3, 0 graphed anyway. So there we go. Now all we're going to do is find the 6 trig functions. So we want to know what sine theta equals, cosine theta, tangent theta, cotangent theta. I think cotangent's next. Maybe. Nope. Secant, cosecant. It doesn't really matter as long as you put the angles in correctly. Cosecant theta and secant theta. Okay. All right, so let's jump out here to this. Now, in this one, you cannot use 9.2, okay? This isn't just simply a y, an x, and all that, so on and so forth, because we're not on the unit circle anymore. If I drew a circle around this stuff, this is no longer a unit distance of 1. The radius is actually longer than that. So the first thing you have to do for this is you need to find the radius. Remember, we have a formula for this, that r is equal to the square root of x squared plus y squared, basically like the Pythagorean theorem. Okay? So we just need to take the square root of the x squared plus the y squared. So we got our x's and y's here. So we plug in. So we got -3 squared plus y squared, which is 0. Okay? R is equal to -3 squared is 9. 9 plus 0 is 9. And the square root of 9 is 3. So now you have your R, we have the X, we have the Y, and you've seen these before. I listed them out back in 9.2, or sorry, back on question 2. So sine is Y over R, cosine is X over R, tangent is Y over X, cotangent is X over Y. Cosecant is the reciprocal of sine, so that's R over Y, not X. Silly Mr. Armstrong. This is why we do things in pencil, not pen, so we don't have to keep doing this. But because I need my answer keys to be more permanent than everything, I do them in pen. Again, pen is the devil to mathematics. So secant is the reciprocal of cosine, so that's R over X, and this should have tried. So there we go. Then we got our Y. So now you just plug in, plug and chug. And then reduce. So this is 0 over r, which is 3. 0 divided by 3 is 0. There's sine. Cosine is equal to negative 3 over 3. And negative 3 over 3 becomes negative 1. There's your cosine. Tangent is equal to 0 over negative 3. And that becomes 0. Cotangent is equal to negative 3 over 0. Remember that we cannot divide by 0. If you go to your calculator, you get an error. So remember, we call this undefined. Cosecant is equal to 3 over 0. So again, this is undefined. And secant is equal to 3 over negative 3, which when divided out gives you negative 1. And there are all 6 trig functions: 0, negative 1, 0, undefined, undefined, and negative 1. Just make sure that you put them in the proper spot when you come over here. So when we come here, we know that we've got, woo, crazy mouse. Slow down there, cowboy. 0, negative 1, 0. Cosecant was undefined, so we'll select B. Secant was negative 1, and cotangent was undefined, so you'll select B. Okay? All right, the next one, number 7. 9 point. This one might be still in 9.5. Let me double check that real quick. I think it's still in 9.5. Just want to look at something. Nope, this is a 9.6er. That's what I thought. Okay. So this is 9.6. So we want to know what is cosecant pi over 3. Okay. So for this one, remember, you all should know quadrant 1 of the unit circle. You should have that memorized. Okay. So quadrant 1 of the unit circle, hopefully you have memorized. So let me show you what I've got here. So this is just my trig sheet. But you should have all that information right there that I'm showing you memorized. You should know these. Okay. Because if you know quadrant 1, you know everybody else's information. Okay, the whole unit circle. So right here, since you have this memorized, you can just look it up. Cosecant pi over 3. Here's cosecant. Here's pi over 3. So 2 square root of 3 over 3. There's your answer. 2 square root of 3 all over 3. Okay? So there you go. 2 square root of 3 all over 3. Because this is just a quadrant 1 angle. And you should have quadrant 1 memorized. Okay? Now, when we get to the next question, so again, this is 9.6. The next question is still 9.6. Okay? So the next question is still a 9.6 question. Just double checking something real quick. Okay, yep. All right, so here, they want us to find the 6 trig functions for this guy. All right, so 8, still 9.6. Almost done with chapter 9. So the first thing is, we don't want to deal with a negative angle. Okay? So step number 1 to this, we want to turn this guy coterminal to be the least positive coterminal. So all we're going to do is we're going to add 2 pi. Again, though, if you don't like working with this angle in radians, change it to degrees. If you turn this into degrees, let me tell you what it is real quick. It'd be negative 225. So, and then all you would do is take negative 225 and add 360 degrees to it. Okay? So, what we end up with is, if you did this, the angle would be a positive 135. And so as radians, that's 3 pi over 4. Okay? Now that we know this angle, and this is in quadrant 2, we're going to use reference angles to help us out. Because again, all the reference angles come from quadrant 1. So because we are in, so let me write down some steps real quick. So the first thing we did, find the least positive coterminal angle. That's what we did right there. Now, the next part we're going to do is we're going to find that reference angle. So remember, find the reference angle. So if we're in quadrant 1, that is the reference angle. If you're in quadrant 2, you're going to take 180 minus the angle. Or in other words, pi minus the angle. If we're in quadrant 3, we will take the angle minus 180 degrees, or pi. If we're in quadrant 4, we will take 360 degrees, or 2 pi, minus the angle. Okay? So I'm going to take 3 pi over 4, and we're going to subtract pi from it. And mess that up. Or in other words, you're going to take the 180 minus 135, because that was what the angle was. But for us, I'm going to keep it in radians, so it's pi minus 3 pi over 4. Or in other words, again, 180 degrees minus 135 degrees. And that will give us pi over 4. So all these answers right here for this guy are going to be determined by sine, or by pi over 4. So sine negative 5 pi over 4. So we can start to figure these answers out. Cosine negative 5 pi over 4. Tangent negative 5 pi over 4. Cosecant. Sorry, I'm just writing out the trig functions now real quick. Hold on, I'll pull up my page. See, I'm just writing out my trig functions. Cosecant, I'll put in the S a second ago, I just messed up. Negative 5 pi over 4. Secant, negative 5 pi over 4. And cotangent, negative 5 pi over 4. Okay? So all these answers are going to be based off of as if it was pi over 4. And again, you have quadrant 1 memorized. So we know that this is the square root of 2 over 2. This is the square root of 2 over 2. This is 1. This is square root of 2, square root of 2, and 1. So these are all the answers. Okay? So the next thing we did is find answers based off of the reference angle. So I just treated these all as if they were pi over 4, pi over 4. And these are the answers to pi over 4. Now the last thing you're going to do is check signs. So remember that we have all students take calculus. All students take calculus. So this means that in quadrant 1, everybody is positive. In quadrant 2, this means that sine and its reciprocal, cosecant, are positive. In quadrant 3, tangent and cotangent are positive. In quadrant 4, cosine and secant are positive. So because our original angle is in quadrant 2, all of our answers are negative except for sine and cosecant. So sine's positive, cosine is negative, tangent negative, cosecant is positive, secant is negative, cotangent negative. So there are all of our answers. The only two that are positive are sine and cosecant. Again, this is why you really only need to know quadrant 1. Okay? All right. Moving on. Number 9. Number 9. Okay. So this is the last of chapter 9, or at least it should be. This is coming from 9.7 when we had right triangles and you're doing with like opposites over adjacents and things like that, and it's a word problem. So it says, suppose you are headed for a plateau 45 meters high. The angle of elevation to the top of the plateau is 40 degrees. How far are you from the base? Okay. 45 meters high, 40 degrees. Okay. So I'm going to draw a picture of this. So we're going to a plateau. Up here is the top of the plateau. Here we are down here. Okay. The plateau is 45 meters high. Angle of elevation, it said. Remember, angle of elevation, there's that horizontal line from your eye. And as you look up, that angle of looking up is 40 degrees. They want to know that guy. How far are you from this? All right. So in 9.7, remember this is your SOHCAHTOA. SOHCAHTOA. Okay. All right. So with SOHCAHTOA, this is our base angle. Let's name everything according to that. So based off of this, here's my right angle right there. Who is this guy? Well, this guy has to be the opposite because it is across from my angle. This guy right here along the bottom has to be the adjacent. Okay? And then the side that doesn't have anything on it, this is actually your hypotenuse because it's actually the longest side. Remember, the longest side and actually the side that is across from the 90 degrees is the hypotenuse. Okay? We don't really need the hypotenuse. We didn't have to put that there, but I wanted to talk about it anyway because that's our hypotenuse. So really, we need something that deals with adjacent and opposite because those are what we're after. We have the x and we have the 45. So if we look up here, that's opposite hypotenuse, so we're not using sine. That's adjacent hypotenuse, so we're not using cosine. TOA. TOA is what we want. So we've got tangent 40 degrees equal to opposite over adjacent. 45 is the opposite. Adjacent is the x. And all we got to do is solve this. Remember that this is just a number, tangent 40 degrees. It's just a number. And as such, that number is actually over 1. So we just use cross multiplying to solve. So we're going to have tangent 40 degrees times x equal to 1 times 45. So we're going to divide by tangent 40 degrees. And that will tell us what x is. Now we're going to go back and we want to check. It says round to 2 decimal places. Okay. So all we need to do, and our angle is in degrees, so we need to make sure that our mode is good. Remember your mode, you just come right in here, and it's this third one right here. So degrees is highlighted, so that's good. So when we do this, we're okay. If that was in radians, it would have messed everything up. So we're going to hit alpha y equals 45 over tangent 40. Close, enter. 2 decimal places, we get 53.63 meters. Because the 8 says, hey, 2, go up. So you don't have to worry about the label meters, it's already there, but you'd put 53.63 there. And that, my friends, right there wraps up chapter 9. Now we jump into chapter 10, starting with question 10. So 10.1, this is all that verifying section. Okay? This is all that verifying section. So they want us to simplify this down to a single trig function, a single trig function or a power of a trig function. So they don't want all this, they just want it to be 1. So we already know this answer cannot happen because that's 2 different trig functions. Okay? So they want it something like these 2, or maybe it could be the number 1 too as well. So let's take a look at what we got here. We got sine beta, tangent beta, all over cosine beta. Now remember that, you know, a couple things that you can do. Remember you have trig identities, like sine is equal to 1 over cosecant, or tangent is equal to sine over cosine, things like that. You have, you know, so you can use identities to help you out. Another way to help you out with this is that you can change everything into sines and cosines. You know, there's lots of ways to approach this. It's going to be what you remember and what you see, because right off the bat, I know 2 ways to approach this and get to the same answer. Okay? So most commonly, what most people do is they change everything to sines and cosines. So we already got sine and cosine here. Let's change tangent to sine and cosine. So sine beta. And then tangent, we're going to use that identity I just said, which is sine over cosine. So there's tangent now. All over cosine beta. Okay? So we multiply across the top on the top. Remember, these are 2 fractions. This guy is actually over the number 1. So if you multiply across the top, you get sine squared beta. All over 1 times cosine is cosine beta. And this is all over cosine beta. Okay? Now remember, we don't divide fractions. We keep, change, flip. So we're going to keep the sine squared beta over cosine beta. Division becomes multiplication. This, remember, this guy is actually over the number 1. So if I take the reciprocal of that, flip it, I get 1 over cosine beta. So all we do is multiply across the top, which gives us sine squared beta, all over cosine times cosine is cosine squared beta. Now, I know this is one of the answers, but remember, they want it as a single trig function. So if you look at this, this should look familiar. Sine over cosine. Oh, I know what that is. Whenever you have sine over cosine using a trig identity, that's just tangent. And because both of these are squared, we call it tangent squared beta. That's the answer thereafter, which was A. Okay. Now, just to talk with you quick, another way to do this, we could have separated this into 2 fractions that were multiplied together. So another way you could have done this was call it sine beta over cosine beta times tangent beta. Oops, you can't see that. So I separated these out. Okay, and this could have been over 1 as well if you wanted it to, but it doesn't really matter. Okay, but wait a minute. We know what sine beta over cosine beta is. Sine beta over cosine beta is tangent. So really all you have here is tangent beta times tangent beta, which gives you tangent beta squared. Okay, so that's another way. Let me actually put in that next piece. So we know this guy turns into tangent beta times, this guy is already tangent beta. And from there, that takes you right back to this guy. So again, lots of ways to go about this. Most people like to change everything to sines and cosines, and this is how it all works out. Okay? But you could also go the other way using trig identities that help you. I turn the sine and the cosine here into tangent. And tangent times tangent is tangent squared. Lots of ways to do it. All right, number 11. 10.2. Oh, sorry, maybe 10.2. Actually, I think it's still 10.1. Yep, still 10.1. Sorry, not a 10.2er. Still 10.1. All right. So they want us to simplify this so that there are no quotients. In other words, no division. So all my answers do not have division, so that's a good thing. All right, so we got sine squared theta minus cosine squared theta all over cosine theta sine theta. All right. Oops, wrong one. There we go. So they want to get rid of the division. That means we got to cancel out the cosine and cancel out the sine down below. Well, one thing that I think about when I see this, and everything's already in sines and cosines, so we're already good on that, is I see this minus up here. Whenever I see addition or subtraction in the numerator, it makes me think like, oh, these were just two fractions that we put together. So let's separate them back out into the two fractions. Kind of like what I just did back on number 10 for that alternate way. I separated them out into the two fractions that originally got multiplied. So since I have addition and subtraction here, let's separate them out into the two fractions that originally got subtracted. So one of my fractions is sine squared theta all over that denominator. Cosine theta sine theta. That was my first fraction there. And it was being subtracted by my second fraction, which features cosine squared theta all over cosine theta sine theta. And now we can actually do some canceling. We couldn't have canceled before because of the addition and subtraction, but now that we've separated them, there's no more addition and subtraction up in the numerator, so we can do some canceling because we have things that occur from the top and into the bottom. So the sine is going to cancel out there, and it's going to cancel out the square part. And that's going to leave us with sine theta over cosine theta. Sound familiar? Yes. Good. I'm glad you agree. All right. And then over here, this cosine is going to cancel out one of those cosines up above, and that's going to leave you with cosine theta over sine theta. Okay? So in the end, we know what sine over cosine is. That's tangent theta. See? No more division. And we know what cosine over sine is. That's the reciprocal of tangent, which is cotangent theta. And that right there leads us to the answer of tangent theta minus cotangent. So D is our answer. All right. All right, so back to our meeting. I had to pause there for a second if you noticed like a little glitch. So right now we're on question number 12, which is still 10.1. So right here we have two fractions. They want us to simplify as far as possible. So I got 1 plus cosine x minus 1 over 1 minus cosine x. Okay. So what they want us to do is they want us to add these, or well, subtract these two together. So in order to do that, that means you need to know what the LCD is, least common denominator. And the least common denominator is actually going to be made up of both of these, 1 plus cosine x and 1 minus cosine x. So we need this to be the new denominator of my two fractions. 1 plus cosine x, 1 minus cosine x. 1 plus cosine x, 1 minus cosine x. Okay? So here's my denominator. Here's what I need. What's it missing? 1 minus cosine x. Yes. So I'm going to multiply the top and bottom by 1 minus cosine x. You guys are so good. Over here, 1 plus cosine x. You're so good. You knew what question I was going to ask. Yay. So 1 plus cosine x. 1 plus cosine x is what this guy's going to get multiplied by. So in the numerator, all we got to do is distribute. 1 times 1 is 1. 1 times negative cosine is negative cosine x. Over here, 1 times 1 is 1. 1 times cosine x is a positive cosine x. So there's what our pieces look like. Now, in this next step, I'm actually going to FOIL this out because I want this FOILed out answer. I'll show you why here in just a second. So if you FOIL this out, because these are conjugates of each other, see how one's plus and one's minus, the middle term's going to cancel out. So when you FOIL this, first, outer, inner, last, one time, all I have to do is really Florida it because they're conjugates. My Florida means just multiply the first and multiply the last. F, L, Florida. 1 times 1 is 1. And cosine x times cosine x is negative cosine squared x. Okay, so I'm going to replace this with my denominators up here because this is important to us. And again, the reason why I can Florida this is because the middle terms are going to cancel out because they're conjugates. Okay? All right. So what we have then is 1 minus cosine x all over 1 minus cosine squared x. And I'm going to take this subtraction and I'm going to change all these signs because you got to be careful of that because we are subtracting off all of this numerator. So what it's going to look like is when I take the opposites of these, when the minus takes the opposite, it's going to turn into a plus. And that's going to give me a negative 1 because the opposite of a positive is a negative, and the opposite of a positive cosine is a negative cosine. And this is all going to be 1 minus cosine squared x. Still the same denominator, it's fine. Just all I did this time now was change the denominators because I FOILed. And because we're subtracting, I went ahead and took the opposites of this second numerator, which the opposite of a positive is negative, opposite of a positive is negative. So now we combine like terms. So 1 plus a negative 1 is gone. Negative cosine plus a negative cosine gives us negative 2 cosine x. Okay? All over 1 minus cosine squared x. Now, this 1 minus cosine squared, we know what this is because we have an identity that says sine squared x plus cosine squared x equals 1. If you move the cosine to the other side by subtracting, you get sine squared x equal to 1 minus cosine squared x. So we could take this sine squared and actually replace this guy. with it. Okay? So we now have -2 cosine x all over sine squared x. Okay? So just some adding and subtracting going on here are fractions, a little bit of FOIL, and then right here we use the trig identity. That's everything that I did in this. So let's go take a look at some answers. Let's see what we got here. So we ended with -2 cosine x all over sine squared x. Well, that doesn't have a -2. That doesn't have a -2, -2, -2. There we go. And the numerator was cosine over sine squared. It's c. There we go. Now, I mean, this thing could have been changed even further, but it didn't want us to. It kept everything in sines and cosines. But we could have changed this even further to actually the real simplified all the way down answer would have been -2 cotangent x cosecant x. That's actually the really simplified down answer version of this. If you want to know how to do that, email me, call me, text me, and we could talk about that. But since they left everything in sines and cosines, the answer was C. Okay. So now it looks like we are actually doing a little bit of jumping. So we are actually jumping out here to find number 13. This is jumping into 10.4, which is all about inverses. So we want to find the inverse of 1/2. Okay? So when you're dealing with inverses, the first thing you want to do is you want to make sure that this answer that they gave us, this x value, is in the domain. So this number right here needs to be in the domain. So the domain, I don't know why I put das, the domain. The domain give that a second to dry, is -1 to 1. And so definitely we are in the domain, okay? So that means we can now think about its answer, and the answer has to be either in quadrant 1 or in quadrant 2. So that means we can actually just go to our calculator and let it kick out the answer for us, okay? Because our calculator will kick out which quadrant this answer actually falls in, okay? So even better. So you just go to your calculator now, and you hit second cosine. So there's the inverse. And then you just put in your fraction. Alpha y equals 1 over 2. Close it. And there is our answer, which is definitely the quadrant 1 answer. Okay? So 60 degrees. The reason why I put this information about quadrant 1 and quadrant 2 because there are two angles where cosine is a half. One of them is at 60 degrees and the other is at 300 degrees. So we throw out the 300 because it's not in quadrant 1 or quadrant 2, because that's where the answer to this question has to lie, in quadrant 1 or quadrant 2. So we throw out the 300. Okay? So we just let our calculator do the work for us. Yay. All right. So number 14. Moving on. So again, we're doing inverse. This time it's arc cosine of square root of 2 over 2. Again, this is 10.4. Okay? So arc cosine. So again, if you think about the domain, it's the same domain. Okay, go back to my little page here. Arc cosine is the same thing as just saying cosine inverse. So these two are saying the same thing. So -1 to 1. And if you go to calculator and take the square root of that, square root of 2 divided by 2. There's our value, and that's definitely between -1 and 1. Okay? And again, our answer must be between or in quadrant 1 or quadrant 2. Okay? So you just let the calculator do the work. Second cosine, alpha y equals second x squared, put your 2 in there, all over the 2, scroll out to the side, boom. All right. The answer is 45 degrees because that's definitely in quadrant 1 and quadrant 2. But again, the reason why I put that is because there really are two angles, 45 degrees or the other one, sorry, not or, and the other angle where it is square root of 2 over 2 is 315 degrees, which we throw out the 315 because it's not in quadrant 1 or quadrant 2. All right. Question 15. So 10.4 is where this one is coming from. Okay. All right. So in this one, we have cotangent, secant inverse of u divided by 2. And they want us to write the following as an algebraic expression where u is greater than 0. Okay. All right, so here it is written down. Now, this one's a little different than probably what you might have experienced in your assignment. So in this case, we need to think about these in terms of triangles. Okay. Remember, this is an answer that you're trying to go backwards on. So another way of thinking about secant inverse u over 2 is to think of it in terms as, again, remember, this is the answer to what secant is. Okay? And then think about this in terms of a right triangle, where this is our angle. Secant is made up of r over x. So again, if you're thinking about this as a circle on the xy axis, our r is u. There's our radius. Our then obviously the x is 2. Oh, sorry, I put the r in the wrong spot. This is our r. Our r is u, and our x value is actually 2. Okay? We want to figure out what is cotangent. So now that you have this information all down, okay? Or in other words, again, if we're thinking about like a right triangle, secant is the reciprocal of cosine, which cosine is adjacent over the hypotenuse. So you can also think about this as the hypotenuse over the adjacent. as another way to think about that. Okay. So we want cotangent. So we now know what this looks like. So you don't have to worry about this part anymore. This part was to help you figure out what your triangle looks like. Okay. So now we just want to find cotangent. What is it equal to? Based off of this same angle. Well, remember, cotangent is the reciprocal of tangent. Tangent is opposite over adjacent. So the reciprocal of that would be the adjacent over the opposite. So we already know what the adjacent is. That's this guy. This is the hypotenuse, or your R value. This is the opposite. So we need to do a little bit of work and find out what the opposite is, okay? Because we already got the adjacent. The adjacent is 2, okay? So we need to find the opposite. How do we find the opposite? It's Pythagorean theorem. A squared plus B squared equal to C squared. A squared plus B squared equals C squared. Okay? Well, here is our A. So let's just call it 2 squared. Our B, we don't know. That's what we're looking for. So just call it question mark squared. Well, I don't want to call it question mark. I already have a question mark right there, so I don't want you thinking that it's the angle. So we'll just call it, we'll just leave it as B. You know, that's fine. Nothing wrong with that. B squared, and our C is U. Okay, 2 squared is 4 plus B squared equal to U squared. Subtract 4. B squared is equal to the square root of U squared minus 4. Sorry, I think I didn't mean to put the square root. I just alluded to the answer. B squared is equal to U squared minus 4. And then how do I get rid of something squared? Square root both sides. So B is equal to plus or minus the square root of U squared minus 4. But because U is always going to be positive, okay, we really want to keep this up above. So I believe you're going to only be looking at the positive version of this anyway. But now that you have B, we can actually plug it in now that we have the opposite. U squared minus 4. So all we need to do now is find an answer that looks just like that. We go no further. They don't even want you to rationalize, I don't believe. So let's go back and look. The only one that looks like that is C. And there's your answer. See, there's the 2 over the square root of 4 squared minus 4. Again, we don't worry about the plus or minus, as I said, because it says right here, U is greater than 0. So that's why we only worry about the positive version of it. Okay? U has to be greater than 0. All right. So with that being said, moving on. So a little different. Again, on that one, just to kind of recap, I use this inverse to create my triangle. And then from there, I had to solve for the opposite to make my equation. Okay? So keep that in mind. You got it. All right, now we're going to move into those 10.5 and 10.6 where we were solving. So number 16 is coming from 10.5. Okay, so 6 sine theta plus 3 equal to 0. Okay, so when we solve, all right, we got to get the sign by itself. So minus 3 minus 3. So we get 6 sine theta equal to negative 3. Then divide by 6, divide by 6. Sine theta equals, this becomes negative 1/2. Oh, sorry. I left it on the screen. So we subtracted 3 to both sides. And then oh my gosh, I don't think I've been sharing my screen this whole time. Oh, nope, I haven't. Whew, whew. Scared me for a moment. So we subtracted 3, and then we divided by the 6, and so now we got this. So how do I get theta by itself? Sine inverse. Yes, you're right. We're going to take the inverse of both sides. Sine inverse. Okay? So theta is equal to the inverse of sine at -1/2. Okay? So we need to know, when is sine -1/2? Well, first thing is this in the domain? Because if this is not in the domain, then obviously this is a no solution. So the domain of sine is -1 to 1, a lot like cosine. So this is definitely in that domain. Okay. The angles for sine exist in quadrant 1 or quadrant 4. So when you use your calculator, it's going to kick out one of these two angles. Okay? It's going to kick out one of these two angles. That's what your calculator is going to do. All right? So if we go to our calculator, let's get our first angle, or see if it's possible. Well, actually, no, it is possible because it was in the domain. So we're going to hit second sine alpha y equals -1 over dose. Parenthesis. And so it kicks out -30. So that -30 actually lies in quadrant 4. Okay? They just make it a negative angle. So this -30, which lies in quadrant 4, all we're going to do is add 360 degrees to it, and that will give us the positive region. Okay? So add 360. So in quadrant 4, the real angle is 330 degrees. And we need that positive angle because our answer says we got to be between 0 and 2 pi. Okay, now that's the other thing. Notice our answer, or our region right here, says between 0 and 2 pi. So that means it doesn't like the degrees. So we need to change 330 into radians. So in order to do that, all we're going to do is take that number and we're going to multiply it by alpha y equals 1 over 180. Now, remember in the top there, in place of this 1, there's a pi, but don't put that in the calculator, otherwise it's going to kick out a decimal. We need the fraction. And then all we're going to do is slap pi in the numerator in the end. So 330 degrees is 11 pi over 6. So that's one of our answers, okay? Because there's actually another place where sine is negative at that angle, okay? So one of our thetas is 11 pi over 6. Okay, because we had to add 360 degrees to it. Now, there is one more angle where we are this. Okay, so when we go back up here, we're looking for when sine is negative. What quadrants is sine negative in? And that's quadrant 4, which we have that answer, and quadrant 3. Remember, all students take calculus. A and S is where sine are positive. That means T and C is where sine is negative. Okay? We have quadrant 4, we need quadrant 3. In order to get quadrant 3, we're going to take the reference angle plus 180 degrees. So we need to find the reference angle to this. Well, you actually already know what the reference angle is. It's this guy. Just take the negative off of it. So our reference angle is 30 degrees. So to find our other angle, we're just going to take our reference angle, which is 30 degrees, and add 180 to it. Or 180 degrees plus 30 degrees. And that gives us 210 degrees. That is another angle where sine is a negative 1/2. But again, we want the radian version of this. So we just go back to our calculator. I'm just going to come up here, change this guy to 210. So that gives us 7 pi over 6. And those are our two answers. That's what they want. In the blank, you will put 7 pi over 6, comma, 11 pi over 6. Okay? So real quick, how do we do that? First we solved, and I used my calculator to find that first angle. My calculator kicked out a negative angle, so I had to make it coterminal. So I added 330 or 360 to it, and there's my first angle in quadrant 4. But I had to turn it into radians, and that's what I did right there. I multiplied by pi over 180. Then, because there are two places where sine is negative, the fourth quadrant and quadrant 3. So I had to find quadrant 3 by taking the reference angle plus 180. Well, this guy actually was the reference angle. Just take off the negative. And so if I take 180 plus 30, I got 210. And that is the other angle, 7 pi over 6, where sine is a negative 1/2. Okay? If you are trying to find some other pieces, so if you're in quadrant 1, you just use the reference angle. If you were in quadrant 4, you would take 360 degrees minus the reference angle. If you were in quadrant 2, you would take 180 degrees minus the reference angle. Okay? To find that second angle depending on which quadrant you were in. Okay? All right. Number 17 is going to be a lot like this. And number 17 is coming from, just kind of looking ahead real quick, 10.5 as well. Okay? Almost done with chapter 10. So we got 2 cosine squared x plus cosine x minus 1 equal to 0. So you can do a couple things with this if you want. Sorry, wrong one. You could run the quadratic formula on this. You don't have to if you don't want to. Or you can factor this because this is factorable. Think of cosine squared x, and cosine here as just a fancy way of saying x. Let x represent that whole piece. Okay? So if you look at this, then all that really means is you got 2 x squared. Sorry, let x represent just cosine, not cosine squared. So if I let x represent cosine, I've got cosine squared here, which means that it's x squared, plus cosine x is really just x, and then minus 1. See, it's just a quadratic to factor. No harm, no foul. And so it does factor nice and easy to one of these is going to be a plus, one of them is going to be a minus. Both of these have to be 1s. Let's make that. This is the minus, that is the plus. Making sure. Yep. So there's what it factors out to. And then now all you got to do is just put the cosine back into it. So 2 cosine x minus 1 and cosine x plus 1 equal to 0. So how do we solve this? Set both of these pieces equal to 0. 2 cosine x minus 1 equals 0. Cosine x plus 1 equals 0. Okay? So we solve just like what we did on number 16. Plus 1. 2 cosine x is equal to 1. Divide by dose. Cosine x equals 1/2. How do I get x by itself? Inverse it. So x is equal to whenever cosine inverse is 1/2. Over here, all you're going to do is subtract 1, subtract 1. Cosine x is equal to -1. Take the inverse, just like what we did on the other one. And x is equal to whenever cosine inverse is -1. And again, we could talk about the domain. Domain is easy, just like the domains we dealt with before, -1 to 1. Remember that the answer to this, if we use our calculator, will fall in quadrant 1 or quadrant 2. Okay? So if we go to our calculator and we type in second cosine, alpha y equals 1/2, close it. One of our answers, and let's see what they wanted in. In this one, they're saying all of our answers, they look to be in radians, okay? In radians. Approximate answers need to be rounded to 4 decimal places. Well, we don't have to worry about that because we're going to get nice, neat answers. All right, so radians it is. So we end up with 60 degrees, but in radians, 60 degrees is pi/3. That's the quadrant 1 answer. Over here on the other side, because this was 60 degrees. I said pi/3, right? Yeah. Okay. Then over here, this x, if we use our calculator, second cosine -1 gives us 180 degrees, which that is just pi. All right. Now, again with these, there are other places where these occur, okay? There are other places where these occur. So let's talk about the 60 degrees. So again, all students take calculus. We are trying to find when cosine is a positive 1/2. So we are dealing with when cosine is positive. Well, we already have quadrant 1. Where is the other quadrant that cosine is positive? Quadrant 4. Okay? So again, remember those little things I gave you? This is the reference angle. And here you'll take 360 degrees minus the reference angle. In quadrant 3, you'll take 180 degrees plus the reference angle. In quadrant 4, you'll take 180 degrees minus the reference angle. Okay? So, sorry, in quadrant 2, I think I might have said this was quadrant 4. My bad. So we already have this guy, which is cool. This is the reference angle. So all we have to do is take 360 degrees minus that. 360 degrees minus 60 degrees gives us 300. That's the other angle. You just got to turn it into radians. So just take 300 times alpha, sorry, second quit. Scroll over. Alpha y equals. I probably should have just went up and grabbed the 210 and all that, but my bad. 180. And this guy is 5 pi over 3. Okay. So our two angles right here are pi over 3 and 5 pi over 3. Our angle over here is just pi. And cosine, so for this guy, for the last one, I mean, if you come out here and look at your answers, there really isn't another angle for this one. Because if you think about this, cosine has to be a -1. And this is at pi. Or in other words, what we're saying here is x has to be -1. Is there another place where x can be negative? A -1? No. And again, if we look at my little map right here, 180 degrees actually falls on this line. There's no other place. It doesn't fall in quadrant 2. It doesn't fall in quadrant 3. Since it's on this line, there's no other place where it will be negative at. There's no other place where this guy will be negative. Okay? So you actually just have one angle for this one. All right. So now we have our three angles. We have pi over 3. We have 5 pi over 3. We have pi. The last thing they want you to do is tell us every possible exact solution. Okay? So that means anytime we are these three angles, we're a solution to this problem. So that just means we need to think coterminal. And how do I make these coterminal? We add or subtract 2 pi. Or in our case, when we want to be coterminal with all these, it's 2n pi. Where n is an integer. So the 2 pi represents the coterminal. The n lets us do the adding or subtracting. If n is positive, we're adding 2 pi every time. If n is negative, because that's what an integer can be, negative, it means we're going to subtract from this 2 pi. So this right here lets us be coterminal forever, as long as n is an integer. And that's the answer we're looking for. Which one looks like that? So if we come out here, here's 3 pi over plus 2 pi n, good. Here's 5 pi over 3 plus 2 pi n, okay, good. Pi plus 2 pi n, n is right there, it's A. The rest of them all mess up. Here is pi halves, that's not even an answer for us. Here is pi over 3, that's good. Here's 5 pi over 8, that's incorrect. Okay, so the answer is A. All right. So that was number 17, number 18. We're kind of gonna jump back here, number 18 and number 19 a little bit. Number 18 takes us back into 10.2, and number 19 takes us back into 10.3. Okay, so this wraps it up. We're kind of a little bit of a jump backwards here, but not much. So number 18 takes us back to 10.2. This is where we're dealing with sums or differences. So what they are telling us is that cosine 5 pi over 12, we want to know the exact answer. Well, that means that this cosine 5 pi over 12 is actually made up of two angles that we know. Cosine plus or minus two angles that we can actually figure out. Well, one thing that might help you is change the 5 pi over 12 into its angle form instead of radians. So take 5 pi over 12 times 180 over 1, and this angle is actually 75 degrees. Remember that you already know quadrant 1. Quadrant 1 is made up of 0, 30, 45, 60, and 90. Is there a way I could use two of those angles to add or subtract to 75 degrees? Absolutely. Okay. But you have actually a whole gambit of angles you actually know about. Okay. So there are lots of ways that we could get to 75. Like, for instance, if I took 120 minus 45. I don't know if you'll have this for your exam or not, but I'm just kind of giving an example. 120 minus 45 is 75 degrees. Or 30 plus 45 is 75 degrees. Okay? Or we could take, I think, just kind of playing around with some things here. Nope. But what if I did? Just kind of giving you, I'm going to give you another one. So if I take 225 minus 150, I can get 40 or 75 degrees. Okay? Lots of ways to do this. So it's all about what angles you can think to give you 75. I'm going to keep it easy for myself. And I'm going to say this is cosine of 30 degrees plus 45 degrees. Keep it easy. Okay. Or it could be 45 plus 30. It doesn't matter the order. Or if you really want to use their actual radians numbers, it doesn't really matter again. So 30 is, if I remember right, pi over 6 plus 45 is pi over 4. So if I take pi over 6 plus pi over 4, I get 5 pi over 12. Yeah. So it doesn't really matter. So all I have to do is apply the cosine sum formula. And the cosine sum formula looks like this. You're going to take your A plus B and you will have cosine A, cosine B minus sine A, sine B. This is your A, this is your B. So I'll fill in cosine pi over 6, cosine pi over 4 minus sine pi over 6 sine pi over 4. And again, because you have quadrant 1 memorized, you know what these are. Cosine pi over 6 is square root of 3 over 2. Cosine pi over 4 is the square root of 2 over 2. Minus sine pi over 6 is 1/2. Sine pi over 4 is the square root of 2 over 2. Okay? So with that being said, we're going to multiply across the top and the bottom for our fractions first. Square root of 3 times square root of 2 is the square root of 6. 2 times 2 is 4. Minus 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. And then all we're going to do is put these two fractions together because they have common denominators. And that would be the square root of 6 minus the square root of 2 all over 4. That's one way to write your answer. Some, and even the textbook, like to kind of like they do a GCF, they pull a fourth out of this and say it's a fourth times the square root of 6 minus the square root of 2. Both of those are A-OK answers. So you just fill in the blank. Okay? Now this one, they want you to make this side right here look like cosine double angle. Okay? So it's basically kind of like a proof, and you're telling me what you're using here. Okay, as you move through each one. And it's a nice kind of like drop down menu for you when you're in the exam. So right here, we actually just made it multiple choice. Okay, so number 19 is coming from 10.3. It is a verifying piece. So we're taking cosecant squared theta minus secant squared theta all over secant squared theta minus cosecant squared theta. Okay? So, whenever I see kind of like squares going on in here, my mind automatically goes towards trig identities. My mind automatically goes towards those trig identities. So we have some trig identities that we can talk about and do some things with. But, you know, so let's think about some things here. So one thing we could actually do, kind of thinking about this, is we could actually separate these out into two fractions. Separate these out into two, kind of like C here. Okay? But they put a 1 on top, so that doesn't make any sense. They changed this to a 1 up here. Maybe. Just kind of thinking here through some things. So I had to take a slight pause for a moment. I was on the right track. You know, I see Pythagorean identities and things like that. In this problem, though, the first thing is there's supposed to be no minus in the denominator up here. So this should actually just been secant squared theta times cosecant squared theta. So let me show you what that looks like. And then we can go from there, because that's the part that was throwing me off. This subtraction right here should not have existed. So we'll get to some of those Pythagorean identities, but not yet. Okay? So the first thing is, because, you know, as I stated earlier on a problem, oh man, what problem was that? It was problem number, no, too far. Right there, problem number 11. This is a lot like problem number 11. Okay? Remember in this one, because I said that there's addition and subtraction going on in the numerator, we can separate those out. Okay? So coming back down to this, too far. So this first one, we actually know what the blank 2 is going to be. It's going to be a difference of two rational expressions, because all we're going to do is we're going to separate and do some reducing. Okay? So all we're going to do on here is take cosecant squared theta, and we're going to slap that over the denominator. Didn't mean to put that minus sign there yet, which is secant squared theta cosecant. Gosh darn. Again, pen is the devil of math, and I'm showing you why right here. Cosecant theta minus secant squared theta all over secant squared theta cosecant squared theta. Okay? So, and then from here, you can see that a cosecant, and this should be squared. Squared, we'll take out the cosecant squared, which will leave us with 1 minus secant squared theta minus, and over here, the secant squareds will take each other out. 1 minus cosecant squared theta. So there is the first part. And again, this was because, and so you would select C, because of the difference of two rational expressions. Which is C as well. So far, you'll choose C for part 1 and C for part 2. All right, the next one, 3 and 4. Well, from here, 1 over secant squared, 1 over cosecant squared, that just means the reciprocal. What's the reciprocal of secant squared? What's the reciprocal of cosecant squared? Okay, well, the reciprocal of secant squared is cosine squared theta minus the reciprocal of cosecant squared is sine squared theta. And that's the next piece. We want cosine squared minus sine squared, and that's A. And the reason why? Well, what did we do? All we did was we just took reciprocals. Reciprocal identity. Which is C for part 4. So you're going to choose A and then C. And then last but not least, because you have cosine squared minus sine squared, that is cosine double angle. Which means that in the end, all you did was apply B, the double angle identity. So that's the end of number 19, coming from 10.3. So that fifth blank is the double number identity. Or you could say identities, which is B. That goes in the last blank. Okay, and there we go. And that right there ends chapter 10. Now we step into the current stuff, chapter 11. Yay! All right, chapter 11. So we've got this triangle ABC. Okay, and we know big A, which is 41.2 degrees. Little a, which is 8.9. And little b, which is 10.6. And I always like to draw my triangle out for this information. Okay. So whenever I draw my triangle, I always put A, C on top, B over here. So I know big A is 41.2 degrees. Little a is always across from A, so that's the 8.9. Little b is always across from big B, which is 10.6. So the question is, they want to know how many triangles exist. And I don't really like it how it says down here, how many solutions does the triangle have? Because really what they're getting at is they want to know how many triangles are there, not solutions. Solutions would be talking about all the angles and all the sides. Okay? But in this one, this part should just say how many possible triangles are there. Okay, because that's what they're getting at. Because in this, when we look at our picture, what they have given us, and this is why I draw the picture, they have given you angle side side, or as the book would say, SSA, because it's afraid to say ass. Okay, so this is the ass case, angle side side. All right, And I like calling it the ass case because you have to be careful of this because it's the ambiguous case. If you're not careful, it will make an ass out of you. Okay? So when you have the ass case, you're going to use law of sines to help you out. And when you use the law of sines, what you're going to do is you're going to find one of your missing angles, either B or C. When you do this, it is important to note you need to find the smallest, the smaller of the two remaining angles. So between these two, C and B, which one is going to be the smaller one? Okay? And that answer should be B. Should be the smaller of the two. Actually, wait a minute. Yeah. Make sure I wrote this down correctly. A and B. Okay. So between these, we're going to find B next. Okay? All right, jumping back in. Sorry, I had to think about that for a second because actually, if I look at these two, I really don't have enough information to know whether the C is the largest or the smaller between the two. So technically, you just pick an angle. Doesn't really matter which one. Pick an angle and find out the measure of it. So it doesn't really matter if you pick what you think is the larger or the smaller in this one. It's probably because I was thinking of law of cosines and all that, and it's got me jumpy. And I'm trying not to make an ass of myself on this case, since it's the ass case. All right, so we won't worry about that. Got rid of that little line. So I'm just going to go with B, since I already know the most about B. Okay. So I wouldn't find C first. I'm going to deal with B because I know little b. And that makes a little bit more sense now. So we're going to have 8.9, which is the side of A, over sine of A, which is 41.2 degrees, equal to B, which is 10.6, sine of B. All right. So from here, cross multiply. So 8.9 times sine B gives me 8.9 sine B, equal to 10.6 times sine 41.2. All right. And then now let's get sine B by itself. So divide by 8.9. So sine B equals 10.6 times sine 41.2 degrees divided by 8.9. So how do I figure out what angle B is? Sine inverse. Yay, you guys are so good. Sine inverse. All right, so B is equal to, and we're going to go to our calculator, we're going to run this. Now, if our calculator kicks out an answer, then that means we either have one or two triangles. If our calculator says error here, then that means you have 0 triangles. So 10.6, parentheses, sine 41.2, close, close, go to the bottom, 8.9, and I always like to scroll out and close everything up. So as long as our calculator kicks out an answer, we have 1 or 2. If our calculator says error, the answer is 0. Oh, we got an answer. So we got 51.67506299. Okay, because we're not really, in the end, we're not going to do any rounding. They just want to know is the answer 0, 1, or 2. So we now know that there is at least 1 or more triangles. So we've got one angle right here. This is what, sorry, 1 second. This is what B1 will be. Well, now we got to check and see if there is possible for a second triangle. How do we do that? Well, the first thing you're going to do is you're going to take 180 degrees minus the 51.6750629. Again, I'm not rounding this because I want to be as accurate as possible. In math, you only round at the very end. Okay? So we'll go right back to the calculator. Calculator, we're going to take 180 minus, I'm going to scroll up, grab my number, hit enter, and we get 128.324937 degrees. Okay? So what this means is this is possibly what the second angle will be. Okay? But you got to check it. So you got to check the second angle. And what we need to do in order to check it is we're going to take that 128.324937 and we're going to add it with our angle A we had up here, which is 41.2. And we want to know, is this less than 180 degrees? If this is less than 180 degrees, then you have two triangles. If this is not less than 180 degrees, then you only have one because it means this angle is too big. Okay? So we just need to go to our calculator and check this and see if this is going to be less than 180 degrees. So I'm going to go up there, grab that angle, plus 41.2. And that is definitely less than 180 degrees. So that means we have two triangles. So in the blank, you're going to put 2 because B could be 51.6750629, or B could be 128.324937 degrees. There are two angle Bs. So two triangles. All right. Number 21. Still in 10.1. Okay. So they tell us big A is 39.2 degrees. Little a is 3.5. And little c is 15. All right, so this time they want us to find everything out about it. Everything out about it. And by looking at this, I see that it says 0, 1, or 2. So this is probably that ambiguous case. So let's draw a picture. Let's just make sure. So big A, 39.2 degrees. Little a is over here because it's across from big A's angle. There's big C, there's big B. Little c is across from big C, so that's the 15. So they want us to find angle C, angle B, and little b. So again, the first thing we got to do is we're going to find one of these two angles. And the angle we're going to find is actually C this time because they gave us little c. So we're going to have 3.5 over sine 39.2 equal to 15 over sine C. All right, so we cross multiply. So that's 3.5 times sine C equal to 15 times sine 39.2. Divide by 3.5. Sine C is equal to 15 sine 39.2 all over 3.5. And take your inverse. Sine inverse, sine inverse. So C is equal to, go to our calculator. I'm just going to come right back up here, kind of grab this guy and modify it. So we know this bottom is actually 3.5. We go up to the top here, scroll over and change this guy first. 15, and then delete, and scroll over, make this 39.2. There we go. Like to scroll out to the side here and enter. Oh, so it says there's an error. So with that, that means we are done. There is no angle C because this does not work. So that means there are no triangles possible for this. There is well, actually, this triangle does not exist, plain and simple. So in the end of this, we say there are no triangles. So we come out here and you will select C, no possible solutions, because there aren't any triangles. Okay, moving on. All right, so number 22. Here you got your little word problem from that section. So 10.1. And just drawing my picture. In the end, they want to know what is the distance from A to B. What is the distance from A to B? All right. Sorry, I drew my triangle a little too big on my paper. So we've got B, C. Put two B's by accident. Again, pen is the devil. Stay away from it. A. We're looking for A to B, so I put an X there. 344 meters, 112 degrees, 14 minutes. 12 degrees, 20 minutes. Okie dokie artichokes. Here we go. So we're looking for that guy. When you look at what you got, you've got an angle, side, angle. Angle, side, angle is law of sines. Law of sines only works on three cases. It works on angle, side, angle, 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 side, or as the book calls it, side, angle, angle, or side, side, angle, which is the ass case. Okay? So all we want to do is we want to figure out what this guy is right here. Okay? So in order to do that, the first thing we need to do is figure out what angle A is, because I'm going to use angle A to help me with this, because that's little a. And then we can use the angle C to help us get the side X. Okay? So the first thing is I need to figure out angle A. And that's easy to do. All we're going to do is take 180 degrees minus 112 degrees, 14 minutes, minus 20 degrees, 12 minutes. And you can do this all in your calculator. And it's okay to leave it in minutes. You don't have to let it be decimals for these and get the exact degrees. You can let it be in minutes and degrees. So we just go to our calculator, 180, hit second apps, angle, so 180 degrees, minus 112 second apps, degrees, 14 second apps, scroll down to number 2 for minutes, minus 12 second apps, degrees, and 20 second apps, minutes. Hit enter. And there it is. Now this is all in degrees, but we want it in degrees and minutes. So again, hit second apps, scroll down to number 4, which is degrees, minutes, and seconds. Hit enter, enter, and there it is. There's the measure of angle A. 55 degrees, 26 minutes. Okay? So now that we know what angle A is, we can solve, because we know this is 55 degrees 26 minutes. So using law of sines, so that's 344. I put 244. Gosh, need to quit messing up. All over sine 55 degrees, 26 minutes equal to x over sine 12 degrees, 20 minutes. So again, all you're going to do is cross multiply and solve for x. So when we cross multiply, we get 344 times sine 12 degrees, 20 minutes equal to x times sine 55 degrees, 26 minutes. To get x by itself, divide by sine 55 degrees, 26 minutes. And x is equal to, they want us to, it doesn't say where to round. I'm going to say probably to the nearest meter. So let's round to the nearest meter. And then you're going to have to pick what the label is. Is it cubic meters, meters, or square meters? And technically, I just gave away the answer. So if you're listening, now you got it. So let's run this in our calculator real quick. So we're going to hit alpha y equals. And we've got 344, not 377. 44, parentheses, sine 12 alpha apps degrees 20 alpha or second apps minutes close all over sine 55 second apps degrees and 26 second apps minutes close. And it actually kicked out a fraction. That's weird. Usually it doesn't do that. So just type that fraction in as division. Divided by 4264. So it is a distance of 89 meters. Okay. So on this one, you got to put in your number, which I think it wants you to round to the nearest whole number, if I remember correctly from exam 3, nearest whole number. And then cubic meters is for volume, meters is what we want, square meters is for area. So just when you're looking at this, know that you'll have to pick meters for this. Okay, so 89 is the answer, meters. All right, 23. This is coming from section 11. Sorry, on those last two, I think I said 10.1 and 10.1. Those are 21 and 22 are actually from, and the same thing, I think, for number 20. I think I put it on. Oh, nope, I didn't. These are all from chapter 11. Gosh. So number 20 is 11.1. Number 21 was 11.1. Number 22 is 11.1. And number 23 starts 11.2. Number 23 starts 11.2. Kind of fixing that. Sorry about that. I think I said 10 ones on all those. No, I meant 11.1. But number 23 is coming from 11.2. Make sure I got that right on the other one. Yeah. Okay. All right. So number 23 and 11.2, this is where we were talking about law of sines and law of cosines. Silly me. And law of cosines works when you have side, 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 or side angle side. Okay. So, and here they want us to find the angle, theta. All right. Now, when you're dealing with this, law of cosines, you got to be careful. Because in law of cosines, there are certain things that have to happen when you're finding the angles. Okay. So we have side, side, side here because we have all three sides. All right. So we're definitely going to use law of cosines. Now, this is the one where we want to find the largest of the three angles. Super important. We're going to find the largest of the three angles first, which when you look at this, the largest one has to be across from the largest side. All right. So here is my largest side. That means this is the largest angle right here. So we can't find theta yet. We got to find this guy. All right. So in order to do that, let's just call this angle A. So we're going to find angle A. So that means we're going to use a squared equal to b squared plus c squared minus 2bc cosine A. So our little a is the 2 square root of 3. Square that, equal to b squared, which is 2 squared, plus c squared, which is 2 squared, minus 2 times b is 2, and c is 2, and we got cosine A. Okay. So with that being said, doing some squaring. So if I square this, 2 squared is 4, square root of 3 squared is 3, so this becomes 12 because 4 times 3 is 12. 2 squared is 4. 2 squared is 4. 2 times 2 times 2 is 8. Cosine alpha. All right, so we're going to subtract 4, and that will give us 4 equal to negative 8 cosine alpha. Divide by negative 8. Or sorry, I said alpha, but A. Cosine A is equal to negative 1/2. How do I get A by itself? Cosine inverse. Yay, cosine inverse. So A up there is equal to whenever cosine is negative 1/2. Okay? So we just go to our calculator and let it do its job. So cosine alpha y equals negative 1/2. And our angle A will be 120 degrees. We don't worry about finding any other angle. This is the one that we want. Because if you find the other angle, which cosine at a negative 1/2 would be 240 degrees, that's too big for our triangle. Triangles have to add up to 180 degrees. All right. So now we know in our triangle that this is 120 degrees. Now we can find this guy. Just use law of sines. So we're going to have 2 square roots of 3 over sine of 120 degrees equal to 2 over sine theta. All right, so all we got to do a little bit of cross multiplying. So that's going to give us 2 sine 120 degrees equal to 2 square roots of 3 sine theta. Divide by 2 square roots of 3. And now we know that sine theta is equal to 2 sine 120 degrees all over 2 square roots of 3. Take the inverse, and we have now finished the problem, because now you will know what theta is. And theta is equal to, let's go to our calculator, let's have it work this out. Second sine inverse, alpha y equals 2 parentheses sine 120, close, close, all down below of 2 second square root of 3, out to the side, close it, boom, 30 degrees. And that's all you need. Okay? So theta is 30 degrees. That's all they wanted. Again, when you're doing side, 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 the first angle you find is the largest one. You have to find the largest of the 3 first, using law of cosines. And then from there, it doesn't matter what you do with the law of sines. All right. We're getting there. We're getting near the end, I promise. All right. So 24. This one is coming from section 11.2 as well. So it says Clint is building a wooden swing for his children. Each supporting end of the swing is to be an A-frame constructed with 2 12-foot long 4x4s joined at a 30-degree angle to prevent the swing set from tipping over. Clint wants to secure the base of the A-frame to concrete footings. How far apart should the footings of the A-frame be? So let's draw a picture of this. So 12-foot long 4x4s joined at a 30-degree angle. All right. So an A-frame looks exactly as it says. Looks like an A. We know that each of these sides right here, because there's only 2 of them, they're 12 feet. We know they are joined at a 30-degree angle. Down here is where he wants to put his concrete blocks. He wants to know how far apart are they. Okay? So what do we have here? We have side, angle, side. All right, side, angle, side. Okay, again, this is law of cosines. So the first thing we're going to do on here is we need to find the third side. Well, that's easy. We just use law of cosines. You don't have to do anything crazy on here because we don't need to know what the other angles are. All right. So law of cosines is going to, will be x squared equal to, let's just think of x as c, little c. So x squared equals a squared plus b squared equal to, or sorry, not equal to, minus, and let me put up the real piece there for you, minus 2ab cosine c. So there's our formula, and we're just going to let x represent the c. So x squared equals 12 squared plus 12 squared minus 2 times 12 times 12 times cosine 30 degrees. I'm just going to go straight into my calculator, let it do its job. So I'm going to go to my calculator. I'm going to put in parentheses 12 squared plus parentheses 12 squared minus parentheses 12 I almost forgot my 2 in front. Insert 2. There we go. So minus 2 times 12 times 12 times cosine 30. Close, close. There we go. Same way I have it written on my paper. And there is what x equals when it is squared. So 38.5846837.1. So that's what x equals when it's squared. But we don't want it squared, we just want it as regular x. So how do you get rid of something squared? You take the square root of it. So we'll hit second square root, come up, grab our number, enter. So there's what x is, 6.211657082. And it says round to 2 decimal places. So 2 decimal places for us will equal 6.21, and it's going to be in feet. That's how far apart the boards will be, the braces. And there we go. Okay. All right, number 25 and number 26, again, coming from both 11.2, and these are all about area, plug and chug. Okay, so 11.2. So number 25, they tell us big A is equal to 11.3 degrees, little b is equal to 12.4 meters, little c is equal to 6.8 meters. So again, if I draw the picture of this, you learn 2 area formulas, one for side angle side and one for side side side. So if I draw a picture of this, this is what I'm looking at. Big A, big C, big B. Little b is 12.4, big A is 11.3, little c is 6.8. So this is the side angle side version they want us to do. And when you do the side angle side version, it really equals, looks like this. Based off of the stuff that we got, it's going to be 1/2 BC sine big A. Okay? So from here, all we got to do is plug in and then go straight to the calculator and let it do its job. So 1/2, B is 12.4, C is 6.8, sine of A, which is 11.3 degrees. So go to calculator, let it do its job. So A is going to be equal to, and it says round to the nearest 10th. So that would be 1 decimal place. So alpha y equals 1/2 parenthesis 12.4 parenthesis 6.8 parenthesis and parenthesis sine of 11.3. Close, close. Enter. So 8.261089441, and rounded to the nearest 10th would be 8.3 meters squared, because it's area. And there we go. So 8.3 meters squared. All right, number 26. We're getting there, promise. Number 26 is 11.2. Okay. So looking at our problem, here they've got little a, which is 16 meters, little b, which is 9 meters, little c, which is 11 meters. So if you draw a picture of this, big A, big C, big B as my normal. So little a is 16 meters, little b is 9 meters, little c is 11 meters. So this is the side, side, side area formula. So when you do this one, this is what we call Heron's formula. The first thing you have to do is figure out the semi-perimeter. Sorry, not a square root on that number yet. So the semi-perimeter, kind of jumping ahead of myself, is equal to 1/2 times all the sides added up. So 1/2 times A plus B plus C. So you just plug and chug. 1/2 times 16 plus 9 plus 11. Again, just go to the calculator. No rounding on this whatsoever. So alpha y equals 1/2 parentheses 16 plus 9 plus 11 z's. Close, enter. So our semi-perimeter is 18. And then now all we're going to do is run the rest of the actual area formula. So area is equal to the square root of S parenthesis S minus A parenthesis S minus B parenthesis S minus C parenthesis. So plug in 18 parenthesis 18 minus 16 parenthesis 18 minus 9 parenthesis 18 minus 11 parenthesis. Just go straight to the calculator, let it do its job. And this says round to the nearest 10th. All right. So second square root, 18 parenthesis 18 minus 16 parenthesis 18 minus 9 parenthesis and 18 minus 11 parenthesis. And we get 47.6235236, which is 47.6 meters squared. And there we go. All right. 27. Jumping into 11.3. And we got 3 problems here where they want us to figure out what A plus B is, A minus B, and the opposite vector of A. So out here, we're going to look at our picture and we're going to actually write down what our vectors are. So vector A is -5, that's the horizontal component, comma 3, that's the vertical component. It's kind of like writing points, but you don't use parentheses, you use like kind of like greater than, less than symbols. So our vector B is 3, comma 4. So the horizontal component is 3, the vertical component is 4. So these are the vectors that we're looking at. So like I said, it's kind of like writing points, but we don't use parentheses, we use like greater than and less than symbols. So all they want us to do is add these two, subtract these two, and give me the opposites. So when you look at this guy, you're going to be taking, and I had these two close together. So let me just move this onto the other side. Let's do that. Give me a little bit more room. I should be able to muscle it in. There we go. So all we're going to do is we're going to take vector A, which is -5, comma 3. We're going to add that with vector B, which is 3, comma 4. And then down here, we're going to take that same vector, -5, comma 3. And we're going to subtract 3, comma 4. And then the last one, all we're going to do, it's kind of like we're just going to take the opposite of -5, comma 3. Okay? So when you add these, you just add the x pieces or the horizontal components and the vertical components. So -5 plus 3 is -2. 3 plus 4 is 7. And those are the answers we're looking for. Down here, we're going to subtract. So -5 minus 3, -8. And 3 minus 4, -1. And then we just take the opposite of all these. So that will give us a +5 and a -3. And there you have it. Okay. Number 28. This one is coming from 11.3 as well. And so they're giving us this information and they want us to find out what is the vector. Now you can't just look at the end of the vector to do it like what we did above. We actually have to use formulas. It's just a formula, that's all it is. So in order to find the vector, these are what your formulas look like. Oops, wrong one. You're going to take the magnitude of your vector times cosine theta, comma, that will give you the horizontal. The vertical part will be the magnitude of the vector times sine theta. That's how we're going to find our vector. And the information they gave us in the picture is the magnitude and the angle. So the magnitude of our vector is this number that's right here, 4. That's the magnitude. The angle of our vector, or in other words, theta, is the 30. Okay? So theta is 30 degrees. All right, so all we have to do is plug and chug, and they do want exact answers. So we're going to take the magnitude, which is 4, times cosine 30 degrees. And we're going to take the magnitude, which is 4, times sine 30 degrees. So cosine 30 degrees, that is square root of 3 over 2. And we're multiplying that by 4, comma. Sine of 30 is 1/2. So when we multiply this, you end up with 4 square roots of 3 over 2. But that reduces down to the square root of 3 over 2. Or sorry. No, sorry. 4 over 2 just reduces down to the number 2 square roots of 3. No denominator. It actually cancels out. 2 square roots of 3. Comma, half of 4 is 2. And that's what they're after. That's our vector. Okay, number 29. All right, so number 29, 11.3, they want you to take this vector and write it as a unit vector. Really easy to do. So in order to write this as a unit vector, this is your A, this is your B. All you have to do is plug in the numbers. So -5i plus 0j. That's one way to write it. Most of the time, whenever we have a 0 times this, we just write it like this, -5i. We drop the j. And there you go. 2 ways to write your answer. Okay? Number 30. So a little vector manipulation here. So 11.3. So u is equal to 2 comma -1. and V is equal to 5, 1, and W is equal to 1, 5. And they want you to do 4 times U times V. Well, that's not too bad. So all you got to do is plug in what you know. So 4 times U, which is 2, negative 1. A lot like what we did up above when we did, I think it was number 27, and we had a negative in front. It's just like multiplying through. And then this little piece is a dot product of V. So V is 5, 1. We'll talk about the dot product here in just a second. First, we need to multiply. So this will give us 8, negative 4. Dot product 5, 1. All right, dot products. Here's how you find dot products. So whenever you have the dot product of 2, all you're going to do is take A times C and add that with B times D. Again, remember these are vectors, where in U it's A, B, and in V we call it C, D. So A times C, which is the horizontal components, and we're going to add that with the vertical components being multiplied. So we're going to take 8 times 5 and add that with negative 4 times 1. And we just want to know what that number is. So 8 times 5 is 40. Negative 4 times 1 is negative 4. So 40 plus negative 4 is 36. And that's all they wanted. Okay. Believe we're at number 31. So 31, 11.3. And they want to know, are these orthogonal? All you're going to do is find the dot product. And if the dot product is 0, they are orthogonal. That's what we want to know. U dot product V equal 0. Keep pushing the wrong one. Okay? As long as this equals 0, they are orthogonal. If this does not equal 0, not orthogonal. Okay? So here's your A, your B, your C, your D, just like before. So we're going to take negative 3 times 5. We're going to add that with negative 5 times 10. Negative 3 times 5 is negative 15, plus negative 5 times 10 is negative 50. That gives us negative 65. So these are not orthogonal. If that had been 0, we would have said yes. But since it is negative 65, the answer is no. All right. 32, 11.6. All right. So the first one says, plot the point. Well, that's not too hard. Which picture down below shows that point? Okay. And hopefully you said, looks like we're counting by 2s. That's horrible, but okay. So the correct answer should be A, 4, 3, 0. So you plotted the point, and then now you're going to give 2 pairs of polar coordinates that are between 0 and 360. So the first thing is we got to turn 3, 0 from rectangular into polar. And that is, again, an equation where you're going to take the x coordinate, and what we need to do is we need to turn it into the radius, well, the x and y's. And then you're going to need to find the angle. Okay? And then again, these are going to be formulas. To find the radius, you're going to take the square root of x squared plus y squared. All right? To find the angle, we know that tangent theta is equal to y over x. So we just plug and chug. So 3 squared plus 0 squared. Three squared is 9 plus 0 squared is 0. 9 plus 0 is 9. R is equal to 3. So we've got 3, comma, plug in, tangent theta is equal to 0 over 3. So tangent theta is equal to 0. Take your inverse. Theta is equal to, so we go to our calculator, we run our inverse, second tangent, 0, and the answer is 0. So our answer is, well, give two pairs of coordinates for the point. So one of them is 3, 0. Okay. So that's one of our polar coordinates we can use. Another one we can use, because remember, in order to generate other ones, so we're on number 32, still 11.6. So our main polar coordinate point looks like this. So this is our main guy. Remember that we can make other ones by being coterminal to this. So all we have to do is take our angle and add 3 or subtract 360 degrees to it. So 3, 0 plus 360 is 360 degrees. 0 minus 360 is negative 360 degrees. We can also work with the inverse of this radius. Okay? So the inverse of this guy is negative 3, 0 degrees. And from this, all we would do is add or subtract 180 degrees. So two other ones we can use at the inverse or the opposite of the radius will be 0 plus 180 degrees and 0 minus 180 degrees. So here are 4 angles that we could also talk about. Now, let's take a look at what they want. We already know that one of these is our answer. That's going to be our answer for sure, one of them. Now, if we come back out here, it says all of our answers must be between 0 degrees and 360 degrees. So, obviously, this angle is between 0 and 360 degrees because we can be 0. Is this angle between there? No, because we're not allowed to be 360. Is this angle between? No, it's negative. These have to be all positive. So we know these two are not going to be the second answer. We come over here. Is 180 between these two? Absolutely. That's the other angle they want. Is negative 180 between there? No. So these are the two angles they're actually looking out for. 3, 0 degrees and negative 3, 180. All right. This is the original polar coordinate point. This one is based off of the opposite of that original radius. All right, next one, still 11.6. So they want to know which one is the graph. Well, that's easy. Remember, R means radius, okay? And this just means that it's going to be centered at the origin. So right away, hopefully you know that the radius should, or well, actually, let's just not worry about if it's centered. Here's the easy thing. I don't know why I'm trying to confuse you. Why don't we just talk easy? Go into your calculator, graph this. That's it. There you go. Done. Okay. So go to your calculator. First off, change your mode and make it polar. Okay. Change your mode to polar. So I've changed it to polar. Now hit y equals, push 6. Graph. And there it is. I know it looks oval. That's because my screen is not squared up. If I want to square this up, if you hit zoom and scroll down to number 5, zoom square. There you go. Centered at the origin, like I said. Okay. So you don't have to remember what I said, but generally whenever you have R equal to a number, this is a circle centered at the origin. All right. But easy thing, just go to your calculator, type it in. Oh, look, it's a circle. Yay. So we go back here and we look, there's only one picture that looks like that, and that's B. Okay. So, and again, it's counting by tens down here. I don't like the way they kind of had this laid out because technically, it looks like 6 is right there, but it's 2, 4, 6. It's counting by 2s down here. So just kind of give you a heads up on that. I don't like the way that it's kind of set up, but I didn't draw it, so neither here nor there. All right, so moving on. So the answer to this guy is B. Use your calculator. 34. We got this. We're almost there, I promise. Again, which is the picture? Go to the calculator. So R equals cosine 2 theta, or 7 cosine 2 theta. So we go to the calculator, y equals 7 cosine 2, hit your X button, which is now theta, and graph. And there's what it looks like. So all we got to do is pick the correct picture. So we come back, and it is D. Let the graphing calculator do the work for you. Last question. We did it. We made it. And again, this is coming from 11.6. So they want you to find out which picture is the graph and which one is the equation. Okay. So we got R equals 6 sine theta. Equation and the graph. The graphing should be easy. Just go to the calculator, let it do its job. So we come out here, and all we're going to do is we're going to push 6 sine theta, delete, and it's ready to go. Graph. And there it is. It's another circle centered up here on the y-axis. So which picture looks like that? Hey, it's B. Graph part is done. All we got to do is find the equation, okay? So here's how we're going to find this equation. Here's how you do it by hand. We have two things that we know. We know that R squared is equal to x squared plus y squared, okay? We also know that x is equal to R cosine theta, and y is equal to R sine theta. We're going to use these three ideas. This right here almost looks like this. It's missing an R. So how can I force an R in here? Well, let's just multiply both sides by R. Because if I do that, I get R times R, which is R squared. And I get 6R sine theta. I've gotten the R that I need. And what are some things that we know? What is R sine theta? Oh, R sine theta is Y. But wait a minute. R squared, don't we know what that is? Absolutely. R squared is X squared plus Y squared. All we have to do is turn this into the circle equation that it is. So we're going to move the 6y to this side, and you're going to get x squared plus y squared minus 6y equal to 0. This piece right here, you're going to complete the square on. Those of you going into pre-calculus, completing the square is going to be important for you. Okay, so this right here, you're going to complete the square on. In order to complete the square, you need to turn that piece that we had right there into something that is factorable. So we had x squared plus y squared minus 6y equal to 0. We want to make this factorable. So how do we do that? We're going to find a c value that we can force in here. In order to find that c value, this is how you do it. You're going to take b divided by 2, and then you're going to square it. So this is the b value. So you're going to take negative 6 divided by 2, and we're going to square it. Negative 6 divided by 2 is negative 3, and we're going to square that, which is 9. So what we're going to do is we're going to force in this 9 by adding it to both sides. Just like what we did earlier when we multiplied both sides by r. Okay? Because this is just multiplying by 1. We're going to add in 9, and if I add 9 over here, I add 9 on the other side. So what we end up with is x squared plus, this is now factorable, and factors out to y minus 3 squared. Equal to 0 plus 9 is 9. And there's our equation. Although when it's out here, yeah, they like to take this piece in the end, and instead of writing it as 9, how is 9 really made up? It's 3 squared. So that leads us to the equation of A. That's the equation we have written down. So there's the equation. So the first one is A. And then down here, the graph is B. And that, my friends, is trig and everything that we learned from the beginning of the year all the way through now. Have fun, enjoy, good luck.